Hello, math friends. So, today I'm going to talk to you a little bit about the math that you're working on. So, on Monday, which is today, you're going to be talking about shapes. You're going to continue talking about shapes that have the same perimeter but different area. So, it's the same all the way around, but a different area, which is the inside part of it. And then tomorrow, you're going to go to shapes that have different areas, but the same perimeter. So I'm going to do a little pre-teaching of that and a little review of what you're doing today. You have to bear with me a little bit. I'm trying to draw on my screen, which I'm not the best at. So right now, I just want to show you the one shape I made so far. So I just used this graph paper and I made a shape that was 3 by 3, a square. And I found the perimeter was 3 plus 3 plus 3 plus 3, or 3 times 4, which is 12. And then I found the area. And remember, the area is length times width. So I did 3 times 3 in this case, and that's 9. I know this needs a unit, so let's pretend it's inches. But it really would be like cubes, but inches works. So then I would put my unit for perimeter is just inches. But then if you remember, the unit for area isn't like a straight line. So we say it's squared inches, square inches, or inches squared. So now I have to try to think of another shape that has the same perimeter as this one, but a different area. So what I'm going to do is I'm just going to start to draw a shape that has the same perimeter. What I have to think about in my head as I start to draw it is a perimeter that would equal 12 inches. So I start to think about it. Well, 12 is 6 plus 6, but I need that to be broken into 4 sides. So what I start to think is, okay, if I did a side that has a length of 5, so 1, 2, 3, 4, 5, and then I went 1 up, that's 6 of my perimeter, and then 6 plus 5, coming back here, that is 11, and then 1 more is 12. And this perimeter, if we look, we have 5 here, we have 1 here, which then would be 5 over there and 1 over there. So the perimeter of this, 5 plus 1 plus 5 plus 1, the perimeter is 12. So it is the same perimeter. Now, right away, I'm thinking that this 12 inches, we'll do inches again. Right away, I'm thinking that this shape has a different area. So area is length times width. So so area would be 5 times 1. What is 5 times 1? 5. So it would be 5 squared inches, or inches squared. That's just like a little shorthand for it. So that would be a shape that has a different perimeter. I'm sorry, the same perimeter, but a different area. Notice how we have 12 and 12 here, and that the areas are different. There's another way you could do this, kind of the same idea. As I draw the shape on this graph paper, I start to add up the perimeter in my head because it will help me. So I start to think like, okay, so if there's 4, 1, 2, 3, 4, so 4, and then I'm trying to think about my first 2 sides of equaling half of 12, which is 6. So 4, let's try plus 2. 4 plus 2 is 6, okay? And another 4, then final 2. So then this would be 4 and 2, and 4 plus 2 is 6, plus 4 is 10, plus 2 is 12. So that perimeter would be the same also, a perimeter of 12. And then the area is 4 times 2, which would equal 8 inches squared. For me, the most helpful thing with doing things that have the same perimeter but different areas and doing any of these problems is graph paper. So I can send you this graph paper if you want it. I'd be happy to if you want to print it out. You also can just Google graph paper PDF and tons of options come up to print. So I'm happy to send it, but if it's easier to just have mom or dad Google it, that works as well. All right, so I am going to move on now to shapes that have the same area but different perimeters, because that's what you're going to be talking about tomorrow. So do a little pre-teach of it. Okay, so now we're thinking about shapes that have the same area but different perimeter. So the same amount that's inside and a different length outside. So again, I'm going to use my graph paper, but I have to switch my thinking a little bit. When I was dealing with the same perimeter, I was thinking about adding the sides together as I was trying to figure out a shape that would work. This is different. What I like to do when I think about a shape that has the same area is I think about a math fact that has the same answer to this one. So my math fact here is 3 times 4 equals 12. Now, in your head, I want you to think about a math fact that also equals 12. There's a few. So we could do 1 times 12 equals 12. We could also do 2 times 6. Doesn't that equal 12? So that's the area I'm going to try to do. So, and then I'm going to check to see if the perimeters are different. So let me count. I'm going to do 2 times 6 because 2 times 6 equals 12. So that would be the same area. So I'm counting up 6. Wait, 1, 2, 3, 4, 5. Oh, I'm just going to fit it in here. And then I'll go back down this side. Okay, so now this is the dimensions are 2 times 6 or 2 by 6. So the area, as we just talked about, 2 times 6 is 12. And remember, it's squared inches or inches squared. Okay, and then the perimeter is what we have to check next to see if it's different. So 2 plus 6 plus 2 plus 6. So 2 plus 6 is 8, plus 2 is 10, plus 6 is 16 inches. Okay. Let's check our perimeters. Are they different? 14 inches and 16 inches, they are different. So that would work. The only thing that sometimes kids will do that this won't really work for is sometimes they switch these two numbers and just make it 4 and 3 here. That's not going to change the perimeter because all the sides, you're just adding them all up. And it doesn't matter what order with addition and multiplication, as you may know. It just matters that the numbers are different. And so if you think of another math fact, just to go over this one more time to think a little bit more about it, we have these two more rectangles. So if we're going to find the area of these two, we would just do 4 times 5, and that would be 20 inches squared. And then we would add up the perimeter. Now, I'm not going to write it all out, but because I think you know how to add up the perimeter, but it would be 5 times plus 5. So the perimeter is 18 here. Okay. Now, I want you in your head to just try to come up with another math fact that equals 20. So do you know another fact that would equal the same as 20 inches squared for the area? You may say 2 times 10 equals 20. 1 times 20 equals 20. But then you might draw a shape that has the area of 2 by 10 and has the area of 20. And then you add up those to get the perimeter. This one over here, our area, our math fact for our area would be 4 times 6, which would equal 24 inches squared. Then you're going to think of a fact that equals 24. You can use any of the fact charts that you've used in school. So, if the facts aren't coming as quickly, because we're really focusing right now on the concept of area and perimeter. So if you need some help with your facts, you can use a calculator to check it, any of that, so it goes a little bit more quickly. So think a little bit about 24 inches, 24 as the area. What could another shape be? You might say 2 times 12. That would work because that area would equal 24. You may also say 3 times 8 because 3 by 8 would also equal 24. It doesn't matter what order these two numbers are in, like you could say 8 by 3 or 3 by 8. Both of those work. So those would all have different perimeters, but the same area. All right, so I hope this little preview into what you're doing, what you're going to be doing tomorrow, and a little review of today helps a bit. I know these concepts can be a little bit tricky, but just keep on plugging along because you're all doing great. So I will see you all on Wednesday and have a good first 2 days of your week. Bye.